Okay, let's go over problem 16.8. It's a pretty common problem. You see a lot of these on midterms and finals, and they're kind of fun to figure out. And so I don't steal your fun. I drew a picture that's similar, but I made up different numbers. So it's basically the same thing, but I'm going to make it slightly different. I just made up different numbers. On problem 8, they want you to find the radius of wheel D. So to make it a little bit different, I said the radius of wheel D is 2. What's the radius of wheel C? So we're going to be finding the radius of wheel C. So it's the same idea, same principles and everything. But hopefully now you can can help you out and you can see how to do these, so then you can try it on 16.8, which the answer is on the PDF file, so you can check and see if you did it right. Okay, so here's the idea. We're going to say this wheel is turning at 10 RPMs, 10 rotations per minute, and so that's omega, right? The angular speed, how many rotations, how fast it's going in a circle, and I just made up its radius is 4. This big wheel we want to go faster at 30 rotations per minute, 30 RPMs, so that's its omega is 30, and I just made up that its radius is 5. Then I said that D, the bigger wheel in the center, has a radius of 2. So to make all this work, what must the radius of the little wheel C be? Okay, so here are the general principles. First, the belt is moving at a certain velocity. Let's call it, since it's attached to wheel A here, let's call it VA. That's this velocity of the belt, right? It's moving along at some speed, which means that the outside of the circle is moving at that speed. And it's attached to wheel C, which means that wheel C's velocity has to be that same thing because the belt's going a certain speed. So VA is equal to VC. Anything attached to the same belt has the same actual velocity. And if you remember, the formula of velocity is R omega. We're going to be using that a lot. And okay, now same thing over here. VD is the same as VB because this belt attaches to wheel B and also to wheel D, so we could say the velocity of D is equal to VB because they're attached to the same belt. Okay, so that's one thing, one way to solve these. The other thing you have to know is if they're attached to the same wheel, like these two guys are attached together, they have the same omega. They have to be spinning the same number of degrees per second or rotations per minute or something, right? They go in the same number of circles per minute because they're attached. So we can say that omega C, the little wheel, since it's attached to D, is the same as omega D. And those are the two things that we use to solve this problem. That the velocities are the same if they're attached by a belt, and the omegas are the same if the wheels are attached, if they spin at the same rate. Okay. Now we know, now it's just a puzzle. Now we just have to figure out what the radius of C is by knowing all this. Okay, so we use this formula. R omega is equal to R omega. So if we have VA equals VC, let's do that first. There's no one, you can start anywhere you want, but let's just start there. So let's say that we'll use this for VA is equal to VC. Well, VA is radius of A times omega of A. So this is radius of A, omega A equals radius of C, omega C. And we want the radius of C. That's what we want to find out. So we have a formula here for it. So our radius of C is equal to the radius of A, omega A divided by omega C. Just put this omega C in the bottom here. Okay, so we just plug in the numbers. So radius of A is 4. Omega A is 10. Now notice we're going to do rotations per minute. And that's okay. As long as we keep rotations per minute everywhere for all our omegas, they're going to cancel out and we'll get the right. We don't need to change it to radians per second or anything. As long as we always have everything in RPMs, the units will cancel because notice we'd have an RPM divided by an RPM. So those things are going to cancel. So the good thing is we don't need to change the units for these as long as they're all the same, which they are, right? RPMs and RPMs. So it's 4 omega A times 10 divided by omega c, and we don't know what omega c is. We just know that it's equal to omega d. So we're kind of stuck. So that's equal to, so RC, we have a formula for it. It's 40 over omega c, but now we got to figure out what omega c is. So we know some other things. Let's see, what else do we know? We know these things, that the velocity of d is equal to vb. So let's see what we can get out of that. vd is equal to vb. vd is a radius of d, omega d. vb is the same thing, radius of b, omega b. Let's see, we want, omega d is omega c, right, because they're attached. So we can change that. So that's omega c there. So, and the radius of d we know is 2. So, so I'm going to write 2 times an omega d. Let's see, they're attached. Yep, omega c is equal to, let's say, the radius of b we know is 5, and we know it's turning at 30. So omega c is equal to 5 times 30 divided by 2. Let's see, that's 150 divided by 2, which is 75. So omega c is 75. So now we can figure out what RC is. RC is equal to 40 over omega c, which is 40 over 75. I can divide both those by 5. That'd be 8/15. And we can change that to a decimal if we like. Let's see, and the units are going to be, well, I didn't even say what the units were. Whatever it is, inches, let's say. So we say if we're dealing with inches. Again, we don't need to worry about the omega c's. We can keep it at RPMs as long as everything's in RPMs, because they're going to cancel, because we're looking for the radius. Okay, so in my problem I made up, the radius of the small wheel is a little over 1/2 inch, right? About 8/15 inches. And the radius of this big one is 2 inches, so it makes sense, right? It's definitely smaller. It's definitely smaller than 2 inches, which is the D wheel, the bigger one. If you get something wrong, you get is bigger than 2 inches, you know you did something wrong. So that's how you do those. You use the fact that the velocities are the same if they're attached to the same belt, and the omegas are the same if they're attached to the same wheel. And I use the velocities the same for the main problem, and right here I use the omegas are the same, because I said, oh, omega d is the same as omega c. Use those two pieces of information to get the answer. So, hope that helps. I think these are kind of fun. And again, the 116.8 is just kind of different numbers, and then you're solving for wheel D instead, but it's the same idea. So hopefully you can do that pretty easily now.